Fan walls are fans configured in stackable or wall-mounted modules that can be designed in various arrays to form a larger fan system. They have a host of benefits over traditional fans used in the HVAC industry that we'll cover in this article. One of those benefits is their simple modular design, which replaces the single, larger, heavier fans of earlier designs. We'll first show you how an air handler gets renovated with a new fan wall system. Here we show a large air handler with one large utility fan inside. The system will be shut down and the fan will be removed. You can see here that the fan was removed from this air handler so that a new bulkhead sheet metal wall could be installed to hold the new fan arrays. So that is what we'll do here. We'll install the bulkhead walls, first the 4 vertical pieces. Then all the horizontal panels, which leaves us an opening in the bulkhead for the fans. Each panel will come from the factory with a sticker that identifies which air handler it applies to and where the panel is to be installed according to the manufacturer provided assembly drawing. Next, the fans will be installed. Here we show what the fan might look like from the side view. Each manufacturer provides similar looking fans with various modifications. Next, we'll put another fan until all 5 are installed. A quick connect box is installed inside the air handler. The quick connect box connects directly to the bulkhead wall and provides quick connection points for all the cabling coming from the fans. Each fan has power and communication wiring connected to the quick connect box. This part of the installation can be done without an electrician, as the connections are just plugged into receptors at each end. A control box will be installed on the outside of the air handler. Then the electrician will run line voltage power to the control box and then over to the quick connection box located inside the air handler. There are cable ties for quickly securing all cabling tight to the wall. The location of these ties is clearly shown on the drawing. Then we install safety devices such as smoke detectors or pressure sensors. Here we represent the main supply air duct. We'll install a high pressure limit switch that prevents excessive pressure from occurring in the main duct. This will be wired to the control box, and if high pressure is sensed in the duct, a signal is sent to the control box to shut off the fans. This also could be any fire life safety device, such as a smoke detector. If smoke is detected, a signal is sent to the fan's control box and the fans are shut off. This prevents smoke from being blown throughout the building. If one fan breaks down and needs to be removed, just replace it with a blank off panel until the new fan arrives. This allows the system to remain running using the remainder of the fans. If this were a single utility or vane axle fan that burned out, the whole system would be down until a new fan was installed. This allows for redundancy with multiple small fans compared to one large fan. Fan walls or fan arrays can be used for built-up systems also. They can be provided in stackable cubes in various configurations. We can have a 1x2 array that is 1 fan high by 2 fans wide, or a 1x3 or a 2x3 fan array. As you can see, you can increase the required airflow by increasing the number of fans in the system. All you need is the space for the fans. As you can see, they easily fit through doorways and up elevators, making retrofit projects easier. The smaller fan cubes are lighter and easier to handle than large fans. This eliminates the need for large cranes or rental equipment. In retrofit applications, large single utility fans or vane axial fans are often cut apart to allow for easy removal down an elevator, along with any sound traps. Fan walls run quieter and generate less vibration than the typical fan and are used without sound traps, which also reduces any pressure drop caused by a sound trap. Here we have a 3x3 fan array, which gives us 9 fans in this system. They're stacked on top of each other and fastened together. Here is a 3x4 and a 3x5. There will need to be a wall that isolates the discharge and suction sides of the fan. This can be done by installing some form of framing on both sides and closing any openings with sheet metal blank-off panels. Now we have 15 fans running in this built-up system, providing air to our building. With all these fans, if any one was to fail, this system has built-in redundancy as there are 14 other fans still running. The fan array also provides better laminar flow as the air is spread out across the coil face area and isn't concentrated in one area as you might get with a single utility or vane axial fan. Retrofits can be done over a weekend when the building is unoccupied, reducing or eliminating any downtime for the AC system. Here are a few ways in which these fans can be controlled with the use of a DDC programmable controller that uses inputs and outputs with the option of a remote control using a building management system. Remember, from our other basic controls videos, that controllers have internal programmable logic, like mini computers that house software specifically for the application of the equipment. See our other control videos on basic HVAC controls or 6 steps for designing HVAC DDC controls. They can be controlled by a supply duct static pressure sensor, which attempts to maintain a static pressure set point, or supply CFM control. They use return airflow control using building pressurization set points, or return air fans can be controlled as a percentage of the supply CFM. There are various other methods of control using the controller. These controllers can be programmed to only run the system during building operational hours by the use of schedules. The controllers can track alarms, scale the CFM of individual fan cells, enable or disable fan cells. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.